Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. Hi, everybody. Tonight, I'll be doing the review for Quiz 3. But before I do that, there's something important I should remind you of. At the end of the semester, you'll take my test number 2 and the ACS final exam for this course, the final exam at the Glen Ellen, the COD Glen Ellen Testing Center. That's the only place you can take that. That's test number 2 and the final exam you have to take at the Glen Ellen, COD Glen Ellen Testing Center. Now, the testing center is only open in the summer from 9 a.m. to 5 p.m. In the winter, fall and spring, it's open a wider window. Why they don't do that in the summer, I don't know, but they don't. If you look at the calendar here, you will have Monday, July 29th, Tuesday, July 30th, and Wednesday, July 31st to take my test number 2 and the final exam at the COD Glen Ellen Testing Center. Now, when I teach this face-to-face on the summer, on the last day of the semester, which is that Thursday, unfortunately, I have to do that Thursday, August 1st, pick up the exams and everything and grade them. So that's why you have to take it on Monday, Tuesday, and Wednesday, because normally in face-to-face, I give it that Thursday, and we have the students first take my test number 2, take a short break, and then come back and take the ACS the final exam. I would highly recommend, and if you want, do it on separate days, but do my test 2 first. I highly recommend you take my test 2 first and then the final exam. Now, you can take it on the same day, any of those 3, but remember on Monday the 29th, Tuesday the 30th, or Wednesday the 31st, you have to take in that time frame test 2 and the ACS final. I highly recommend that you take my test first, test 2 first, and then the ACS final. Now, I should mention the ACS final, I believe, has 60 questions. You'll have 55 minutes to do that. It's a time one, so all multiple choice. And it's the only time I ever curve anything. That final, I will curve to your benefit. All right, let's go through quiz number 3 material. And if you go to Blackboard, you'll see in the lecture section of Blackboard a file cleverly named Chem 1211 quiz number 3 review. And quiz 3, it says test here, but it's really quiz. Should be quiz. Sorry about that. Now it says quiz 3, and that deals with chapter 11 gases. The first thing you should know is an important parameter of gases that you measure is the pressure. And the pressure units are either millimeters of mercury, torr, or atmosphere. As you see here, 1 millimeter of mercury equals 1 torr, and this was corrected. I didn't correct it on this one. And 760 torr equals 760 millimeters of mercury equal 1 atmosphere. And I think I have it open. If you look at important in the same folder, lecture section of Blackboard, you'll see a file, important information, quiz number 3. And here I give you all this information on this one page. Will be on the last page of your quiz 3 when you download it from Blackboard this Thursday. Because remember, this Thursday, I'll be giving quiz number 3. You'll have until Friday to finish it. So we know 760 torr equals 760 millimeter mercury equal 1 atmosphere. And if you look at the practice problems for chapter 11, I also have the answers. Let's look at number 2. How many millimeters of mercury, mmHg, is 1,245 torr? Well, we're trying to find millimeters of mercury. We're given the torr. This is the only number we have to start with. We're trying to get the millimeters of mercury. Whatever you're trying to get to goes on top, whatever goes underneath. I put 1. You could have also put 760 millimeters of mercury for 760 torr, and it's the same number. All right, let's look at number 4. How many torr is 1.237 atm atmospheres? So we're trying to find torr. We're given atmospheres. Here's what we start with. We have some ratio. What would the unit we want to get to? Well, we figured that out, torr. So use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top of the ratio. Whatever you're trying to get rid of goes underneath. And where do we get this numbers to put in there? If you look at important information, 760 torr equal 1 atmosphere. And remember, when you have two things equal to each other, you have two ratios, A over B, and not equal, different ones, B over A. So we have 1 atmosphere equals 760 torr, also 760 millimeters of mercury. And that's where we get the numbers here, 760 and 1. Now, these are exact numbers. So this is 4 significant figures in a multiplication division. You get the same number of significant figures as the number that has the fewest significant figures. Well, there's only one we deal with, 4. And notice my answer also has 4. And you could have also written it 9.401 times 10 squared in scientific notation. All right, now important thing you'll need later, but I put it here. Remember, when you're doing calculation with gases and you're dealing with temperature, it's going to be in Kelvin, K. But every measuring device I've ever worked in a lab does not measure Kelvin, but you do measure Celsius degrees C and convert to Kelvin, degrees C plus 273. Now, I talked about the gas laws. And the first one I talked about was Boyle's law. And Boyle's law is P1 times V1 equals P2 times V2. What's that? Well, here I tell you. P1 is your initial pressure. V1 is your initial volume. P2 is your final pressure. And V2 is your final volume. So let's look at the problem set. And if we look at number 6 and 7 is similar, if a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133 liters? Well, if we look at here, we're trying to find the final pressure, P2. Initially, the balloon has a pressure of 658, which is P1, the initial pressure, and initial volume of 1.894 4 liters. L is liters volume. So that's V1. And you're increasing the volume to 5.133 liters. That's V2. So when you only see pressure and volume and you're dealing with a gas, you know you have to deal with Boyle's law. P1 times V1 equals P2 times V2. Now we're trying to solve for P2. So we wanted a loan on one side. So how do we get rid of this V2 here? Divide by it. Anything divided by itself becomes a number 1. I like those special effects. Oh, that was bad, sorry. But anyways, whatever you do to one side, you have to do the other. P2 times V2 divided by V2 is P2. And here, this is P1 times V1 divided by V2. Now, you don't have to do this, but how should I say, this is a habit of mine. I switched it around and rewrote it as P2 equal V1, P1 times V1 times V2. Now, because we took the time to figure out what is P1, V1, and V2 before we started this, we can put in P1, 658 torr, V1, 1.894 liters, and V2, 5.133 liters. This is 3 significant, 4, 4. Your answer should have 3 significant figures. I wrote it in decimal, 248. It could also be 2.42 times 10 squared torr. Now, let me point out something in problem 7. We're doing the same thing, and I'll let you look at this. Let's look at the numbers here. That's 4 significant. Is that 3? It's still 3. So remember, when you multiply and divide, you get the same number of significant figures as the number that has the fewest significant figures. Now, usually for me, it's 3, but it doesn't always have to be. Hint. All right, next. By the way, I skipped Charles' law. I won't put it on the quiz. Every time I put it on a quiz or a test, everybody almost gets it wrong, so I've stopped doing that. But one of my favorite mathematical expressions in chemistry is the ideal gas law, PV equal nRT. P is pressure, but it has to be in atmospheres. V is volume, but it has to be in liters. N is the number of moles. T is the temperature in Kelvin. And R here is the universal gas law constant. And for this class, you'll use 0.0821 atmosphere liters per mole K. By the way, R for what I'm using is three significant figures. Now, before we do an ideal gas law, let's see something. This is important information. Let me get to the right one. Nope, but I don't have it on here, but you should know. Let's talk real quick about PV equal nRT. And if you've ever driven in a car, which I assume all of you have, the car tires have a gas, usually air, but a lot of times some people now put nitrogen, and I don't. I don't think it's worth the extra money. That's my personal opinion. And gas in your car tires has a pressure. And in PV equal nRT tells you when to check your car tires. In the winter, it gets real cold. The temperature goes real down. And if you back it on, it hasn't been a while since it got super cold here. But I remember one time back in 1995 when the outside temperature, not the wind chill, was close over minus 25 Fahrenheit. That's cold. Well, when the temperature goes down, PV equal nRT. V, N, and R in your tires are constant. And if the temperature goes down, the pressure goes down. So in the winter, because the temperature goes down, the pressure goes down, just check your car tires. And if you watch the video, you'll hear the story I told about that winter in 95 when I walked out and saw, oh no, I got 4 flat tires. I immediately remembered PV equal nRT. The pressure was down because of the cold. I went over to a gas station and I filled all my tires up. This was about 7:38 in the morning on a Saturday, and it was already still 5 or 10 below. I looked up because when I got there, I was the only person filling up my car tires. When I finished, I looked up. There were about 10 cars in line waiting for me to finish. Now in the summer, it gets hot and T is temperature, it goes up. And your car tires, the gas follows PV equal nRT, V, N, and R, and your tires are constant. And if the temperature goes up, then the pressure will go up. And around that same time, in the 90s, about 95 or so, we also had a brutal summer. The temperature for almost 2 weeks, the daytime temperature was never lower than 100 during the afternoon. And I remember coming back on the highway from where I worked, and you saw a lot of cars and trucks over with blowouts because they didn't check their car tire because the temperature went up and the pressure went up so much it blew the tires out. Now let's look at number 10 in the chapter 11 problem set. And if I had this on a quiz, it would be 15 points. Yep, 15 points. Whoa. So let's look at this problem. If you burp 86.75 grams of CO2 gas, carbon dioxide, at 545 millimeters of mercury and 34.6 degrees C, then what is the volume of your burp? Now, this is sort of outrageous problem. You'll see why. I just picked some numbers and they're wild numbers. So we're trying to find volume. We're given a weight, grams of CO2. We're given a pressure, 545 millimeters of mercury. We're given a temperature, and we're given R. Where's R? Well, if you look at, oh, wrong place. If you look at important information, quiz number 3, R, the universal gas law constant of 0.0821 atmospheres liters mole K. Well, how do I know to use PV equal nRT? You're dealing with a gas. Is anything changing? Temperature isn't changing. The weight isn't changing. The volume isn't changing. Nothing is changing. Immediately, that tells you plus 15 points. It's PV equal nRT. What are we trying to solve for? Volume. So we need to get volume alone on one side. Time out for a water break. So how do we get rid of the pressure to get V alone? Anything divided by itself is number 1. So P divided by P would be 1 times V would be V. But whatever you do to one side, you have to do to the other. So I divided by P. So V equal nRT divided by P. Now we have to find what is N, what is R, what is T, what is P. Now, P is pressure. It has to be in atmospheres, but we have millimeters of mercury. So we start to convert it to atmospheres. We start with 545 millimeters of mercury. We have a ratio. We want to get the atmospheres. Whatever we're trying to get to goes on top, atmospheres. Whatever we're trying to get rid of goes underneath, millimeters of mercury. If you look at important information, quiz one atmosphere equals 760 millimeters of mercury. Those are both exact numbers. This is three significant, and here's the answer in three significant figures. Temperature always has to be in Kelvin. Oh no, we were given degrees C. But important information, quiz 3, Kelvin equals degrees C plus 273. In this case, that was 34.6. Now, 273 is an exact number. When you add, well, the only thing is you got one significant figure past the decimal. This is the exact number, and here's the number you get in Kelvin. And N is moles of CO2. Wait, we were given grams, so we have to convert grams of CO2 to moles of CO2. And whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of, grams of CO2 will go underneath. Where do we get the relationship of a mole of a compound and the weight of a compound? Well, in case you forgot, 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight of that compound is the sum of all atomic weights. And therefore, we know the molecular weight of CO2, 1 carbon, 2 oxygens. You look for the atomic weight from the periodic table for carbon and oxygen. Oops. Which is right here. Carbon to 3 significant figures. On quiz 3, it will say under your name, please use proper significant figures for all calculated answers and 3 significant figures for all atomic weights. That's 12.0. For oxygen, 15.999, rounds off to 16.0. And now we know there's 1 carbon, 2 oxygen, each carbon 12.0, each oxygen 16.0, multiplied by 2, 32.0, 12.0, and you get 44.0. Put that here. This is 4 significant, 3, the 1 is the exact number, 3 significant figures. Well, now I have everything to go over here to figure out what volume is. What's N? Well, 1.97 moles of CO2. What's R? Well, we're given that, 0.0821 atmospheres, liters, mole K. What's degrees Kelvin? Not degrees Kelvin. I always do that. It's only Kelvin. It's not degrees ever. 307.6. What's my pressure in atmospheres? This number, 0.717. And if you do the math, it's 3 significant, 3, 4, 3. Your answer is 369.4 liters both ways. If you round off at each step or wait till the very end, you get the same thing. Now, this is not a realistic thing. Think about it. That's almost 35 2-liter bottles of gas you just burped up. Your lungs aren't that big, but it was fun to do. All right, next, Dalton's law of partial pressures, and that's the total pressure of a gas is equal to the sum of the partial pressures of each of the total pressure of a mixture of gases is equal to the partial pressure of each of the individual gases in that mixture, P1, P2, P3. That's partial pressure. And a partial pressure is what would be the pressure of that gas in the mixture if it were alone. Huh. I guess I don't have a problem, so I better make up a problem. Dr. White can do things like that. That's what a PhD chemist can do, among other things. All right, let's look at the following problem. What is the pressure of a mixture of nitrogen and oxygen gases if the partial pressure of nitrogen is 333 torr and the partial pressure of oxygen is 101 torr? So what are we trying to find? The total pressure. That's the most ugliest letter P I've ever written. That's better, P total. What are we given? The partial pressure of nitrogen, P sub N2, is equal to 333 torr. The partial pressure of oxygen is 101 torr. And as soon as you see the word partial or words partial pressure, you know it's time for Dalton's law of partial pressures. P total equal P1 plus P2 plus P3. So what does that mean? For this problem, P total equals the partial pressure of nitrogen plus the partial pressure of oxygen. We took the time, this is 333 torr. Partial pressure of oxygen, PO2, is 101 torr. And if I add it up, that's 434 torr. And that's how you do Dalton's law of partial pressure. And let's continue on. Now, when we talk about pressures and gas pressures, when you boil something like water, you have the water, when it's boiling, forms bubbles of water vapor. Vapor means water gas. And when it comes to the surface, the bubbles collapse. I like that, collapse. And the oxygen, the water vapor gas comes out. And when the vapor pressure of that liquid, that water vapor, equals atmospheric pressure, and you take a temperature of that liquid, we call that the boiling point of water or any liquid, whatever temperature. And at atmospheric pressure, sea level, when the atmosphere is 762 or 1 atmosphere, for water, that's 100 degrees C. Now, when you go higher up on the planet Earth, higher altitude, the atmospheric pressure gets lower. And because of that, you need less energy, heat, to get the vapor pressure of the water equal atmospheric. So the boiling point decreases. And if you go to one of the highest mountains in the world and measure the boiling point of water, it's going to be way down because the atmospheric pressure is way down. And with that, I'm done. Now remember, this Thursday, I'll be giving quiz number 3 online. Also, remember Wednesday, tomorrow, I will have my office hour. And if you need help, stop by. That's why I'm there. It's on Zoom, so you don't have to get in your car and come to COD. Just turn on your computer or your cell phone or whatever. Yes, you can do Zoom on a cell phone. I've had students do that. I had one student do it on a cell phone while I was having someone else drive. He was in a car. But anyways, remember to study, do the practice problems. Also, as I said at the beginning of this video, remember to make plans that on July 29th, July 30th, or July 31st, from 9 a.m. to 5 p.m., you got to get there earlier if you want a full hour to do the test. Don't get there near the end because you won't, they're closing their doors at 5 p.m. You have to take my test 2 and the final. I'd highly recommend you take my test 2 first and then the final. Now you can do it on the same day or separate days. That's up to you. And with that, I'll say, gang gesund. Bye now. Stole that from Granny to Beverly Hillbillies.